Okay. Mike and Andrew were playing a resin game of Guess My Polynomial. Andrew tells Mike, my polynomial is a cubic with a leading coefficient for 1, constant of negative 18, and 3 integer zeros. Mike says, I need more information than that. Andrew replies, okay, the quadratic coefficient is my favorite number, which I told you last week. That's still not enough information, Andrew answers. Fine, 3 of the coefficients are positive. Ah, Mike says, now I know it. What is the value of the largest coefficient of Andrew's cubic? Largest positive coefficient. Okay. So the cubic of x is going to equal x to the 3 plus ax, or I'll do bx squared plus cx minus 18. Okay, 3 of the coefficients are positive. C and b are both greater than 0. 3 integer zeros, okay. The quadratic coefficient is my favorite number, so I'm assuming that means that b is an integer. B is an integer. Okay. I don't understand how this tells us what it is. Okay, so if it's negative 18, then it's going to be, could factor into x minus k times x minus p times x minus q. Two of these are positive. Okay, one of them, two of them. If you multiply these all together, these will give you a negative final one. So they could all be positive. So K, P, Q are all positive. Or two of them can be negative. Okay. Well, if these are all positive, it's gonna be K minus, it's gonna be minus kx plus negative k minus p minus q x squared plus and it's going to be x squared times negative, or no, it's going to be x times, so it's going to be kp plus pq plus qk x minus kpq. Okay. So either they're all positive or two of them are negative, one of them is positive. So kpq is equal to 18, so do they all have integer zeros? Okay, 3 integer zeros. So what are 3 things that multiply to 18? So 18 can go into 1, 1, 118, 1, 2, 9, 1, 3, 6. Okay, then if you further change it like this, you can change it to 2, 3, 3, I think that's it. So the thing is, I don't think this one is not allowed because it repeats 3. This one's not allowed because it repeats 1. So I think it can only be one of these two. In both of them, x equals x minus 1 is a factor in both of them. So if we know x minus 1, so this is really the same thing as x minus 1 times x minus k times x minus, or x minus p, or x minus q, yes. So if x is equal, x minus 1 is one of the factors, we get x cubed plus negative 1 minus p minus q x squared plus p plus q plus k, or no, plus pq x plus k pq, or minus pq, I guess. Okay, let's try 2 and 9 then. If I put 2 in here, 2 and 9. Oh, it could also, oh shoot. No, because it could be the fact that 2 of them are negative. And that would, yeah. Shoot. All of that is incorrect. So, I guess these two aren't allowed. But what we can have is negative 1, 1, 18. Negative 18, I mean. Or negative 2, 3, negative 3. These are allowed. We also have negative 1, 2, negative 9, negative 1, negative 2, 9, 1, negative 2, negative 9. We could also have 1, negative 3, negative 6, negative 1, 3, negative 6, and negative 1, negative 3, 6. So all of these are allowed. These are all combinations of zeros that would work. Okay, so now let's think, well really, okay, they can't all be positive. If they're all positive, then this would be negative. We know that's untrue. So this is just not allowed. These two are not allowed. Okay, now let's try the rest. So, negative k minus p minus q. So if we have negative, so 1 minus 1, 8 minus 18, this one works. This one, it works because these two would cancel out. Okay, 1 minus 2 plus 9, this one works. 1 plus 2 minus 9 does not work. Negative 1 plus 2 plus 9 works. Negative 1 plus 3 plus 6 works. Plus 1 plus 6 minus 3 works. And then plus 1 plus 3 is 4, so this one doesn't work. So now we're left with 6 according when we did this one. Now let's look at this one. This also needs to be positive. So 1 times negative 1 times 1, which is negative 1. So for this one it will be negative 1 plus 18 minus 18. So this one actually doesn't work. Right, so negative 18 plus 18, negative 1. And then same thing here. Negative 6, positive 6, negative 9. This one doesn't work. Positive 9, so we get 9 minus 2 minus 18. This one does not work. We get negative 9 minus 2 plus 18. This one actually does work again. Here we get negative 6 minus 3 plus 18. This one does work again. Then we get 6 minus 3. Well, 6 minus 3 minus 18. This one doesn't work. So now our final two options are 1, negative 2, negative 9, 1, negative 3, negative 6. Interesting. Okay, so we can go back. Both of them do have x minus 1 as a factor. Cool. So if x minus 1 is a factor, then the only, then can we guess the polynomial? How do we know? Oh, okay. What this is telling us, not only, it's not really telling us it's an integer, but that doesn't matter. It's telling us that if we know the quadratic coefficient, we can't determine what it is. So if we know b, we can't determine c. So for which one of these does knowing b not tell us what c is? I don't know, let's find b and c for both of them. So with this one, b is at 11 minus 1, c is equal to negative 2, negative 9, plus 18, so 7. Here b is equal to 6 plus 3 is 9 minus 1 is 8. C is equal to okay, so negative 3, negative 6 plus 18. So negative 3 is negative 3 minus 6, so it's going to be equal to 9. So I'm thinking we only know once we know that 3 of the coefficients are positive. So in which one of these can C be negative given B? Let's look. C is this. So given B, can we find a C that is negative? Given B is 8 or 10, we find a C that is negative. How should we go about this? So in order to do this, we need to find all numbers that multiply to negative 18, that add to 10 or 8, that are, and then find C for each of them. Find the quadratic coefficient. Okay. So we have, again, 1, 118. Can't make anything to add to 10 like that. 1, 2, 9. Even with negatives, you can't make anything add up to 10. Oh no, you can actually. What am I telling you? You could have it like this. We could also have it, 1, negative 2, or negative 1, 2, 9. That adds up to 10. Negative 1, 2, 9. Okay, so that would make B 10. What would C be? C would be 18 minus 9 minus 2, which is still positive. Darn. Okay, I don't think we can make anything else like that. Although we could do 1, 3, 6. There, B is 10. It's positive. But these are all positive, so it doesn't matter. We need to have at least one negative. So 1, 3, 6 doesn't work. 3, 3, 6, 3, 3, 2 won't work. What about 8? Can we think of any that are 8? Take 9 minus 2 plus 1. 1, negative 2, 9. Here 1 is negative. Here 18 is negative. But we need 18 to be positive. 8. So we could do negative 1, 3, 6. That won't work. We could do 2, 2, 2 through 3. That does work. That's up to 8. But this would be positive, so. Have I been doing this wrong? I might have been doing this wrong. I need to make them negative. Because really when you add these up, it will be negative 10. So if I make them all negative, so if I had, for 8 again, if I had 1, 2, 9, so 9 minus 2 plus 1, so it needs to add up to negative 8. So negative 1, 2, negative 9. This adds up to negative 8, which is what we're looking for. And 18 would be negative, and 18 would be negative, and, oh, what would this one be? This would be 9 minus 2, 9 minus 2, minus 18, which is negative. So I don't think it could be this one. I think it has to be 10. Let me check. I'm not sure. Nope, I was close. It was actually 9, but, with 8, I don't know exactly what I did wrong, but I was on the right track somewhat. No, I got it wrong. Thank you guys for watching. I'll see you guys tomorrow. Bye.